All right, here we go. Our objective for today, I can identify the greatest common factor and least common multiple of monomials. Let's read together. 1, 2, 3. I can identify the greatest common factor and least common multiple of monomials. So in the past, you guys already did greatest common factor and least common multiple. They called it GCF. Who remembers GCF? That word, yes. Right. And this was introduced when you guys were in elementary. But I'm going to bring it back to see if we remember and how much we remember. Yes.
What's monomial?
Monomials. Monomials is any number. Good question. Look up, please. Monomials are any number or variable or numbers and variables multiplying, such as this. Look up. A monomial could be a number such as 23. Michael Jordan. It could be a variable such as x. Or it could be both of these multiplying 23x. When they're side by side, it's multiplication. All these are examples of monomials. Or they can also have an exponent, but the exponent has to be a whole number. What are whole numbers? Anywhere from 1, 2, 3, and so on and so forth. Yes.
23.
Bam. Yes.
Can you use any variable you want?
Any variable you want. So if I use an exponent, I'm going to use 5. This is still a monomial. Those are examples of monomials. Okay? So to get us started, look up to the screen, please. So I'm going to introduce a tool that we're going to use for this lesson. And the tool is a Venn diagram. Who's used Venn diagrams before? In language arts, you guys use them a lot, right?
Yeah.
Or you use them every now and then. So watch. Let me show you how a Venn diagram works. Look up to the screen, please. So here's a question. What do I have in common with Michael Jordan? So watch. Let me create a Venn diagram. Here's the circle for Michael Jordan. Here's a circle for me. So let's see. Well, Michael Jordan is tall. I'm not that tall. Michael Jordan is a basketball player, professional. I'm a teacher. Okay. Michael Jordan is rich, big time, and I'm not rich. But look what we have in common. This is one of the things that I remember I saw this in an interview, and this is what attracted my attention to Michael Jordan. Check this out. Our favorite subject was mathematics. He loves math. And guess what? He's one of the professional athletes that instead of losing money, he's making so much money because of the math that he knows. He doesn't have people stealing from him like other players. Yeah.
Oh, okay. The difference. He's dark.
He's dark. I'm not that dark. Yes, thank you. Okay, so, guys, so check this out. How the Venn diagram works, whatever's inside here of the intersection, that's what we both have in common. We both have in what? Common. And this is where I to make sure that we understand, I kind of like highlight it so that we know that this is what we both have in common. So today we're going to be looking at common factors and multiples, and that's why we're going to be using a Venn diagram for this purpose. Okay? So with that said, in your FAIR model, write this down, please. Factors. Factors. What are factors? Factors are two or more numbers that are multiplying. Write that in there, please. Two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. Factors are two or more numbers that are multiplying. So you remember the definition for factors?
Two or more numbers that are multiplying.
Bless you. Let me show you examples. 2 times 5. 2 and the 5 are factors. 2 times 3 times 7. 2, 3, and 7 are factors. 3 times 5 times 11. 3, 5, and 11 are factors. 2 times 2 times 3 times 3 times 5. 2, 2, 3, 3, and 5 are factors. Why are those factors? Let's see, the definition says 2 or more numbers that are multiplying. Okay. Let me show you none examples. Copy those. And as you're copying them, start thinking, these are not factors because... Talk it over with your neighbor. Why are these not factors? Bless you. So, who can share why these are not factors? Ozzy. Because they're not multiplying. Does everybody see that this one's adding, subtracting, dividing? Factors only have what? Multiplication. So, what would be a critical attribute? That factors are what?
Numbers and multiplication or
2 or more, and they are what? Multiplying. 2 or more, and they are multiplying. Write that in there, please. All right. Let's see if we got this. So once again, factors are 2 or more numbers that are multiplying. Factors are 2 or more numbers that are multiplying. Do I have here 2 or more numbers? Yes. Here, yes. Here, yes. And here, yes. All these are factors. These are not, and we said because they don't have multiplication. So that's why the critical attribute is 2 or more, and they are doing what? Multiplying. Yes, Carlos?
So if they're multiplying and you have a division, is it still a factor?
Only the ones that are multiplying are factors.
Okay.
Yeah. Yes?
I was gonna say that.
Okay. All right. So check this out. Let's see if you know what factors are. Look up to the screen. It says, what is a factor in your own words? Which of the following is an example of factors? So look at the example that I'm going to give you. Turn to your neighbor, let them know which one of these, either A or B, are factors. And in your own words, tell them what a factor is. Go. Which of these pairs are factors? B are factors? A. Why are they factors? Because they're 2 or more and they're multiplying, okay? So in your own words, what is a factor? Let's say your BFF wasn't here, and they kicked you in the afternoon, or they Instagram you, whatever it is you guys do. Yes?
How can they kick you if they're not here?
That was funny. Hey. How can you make kick like?
Are you serious, or are you being...
I'm not getting, how can they kick?
Okay, there's this program called Kick.
Oh.
Anyways, so they send you a message electronically. Let me rephrase that then. Ramon, what would you tell them if they said, what you guys doing, Mr. Q? Well, we covered factors. What's a factor? What are you going to write? Yeah, simple, straight to the point. Yeah, we got this? All right, thank you. So, look at this next part. Look up, please. You don't have to copy this one. Look up. A multiple is the product of any amount times an integer. Product means the solution of a multiplication. That's what a multiple is. Watch. 2 and 3 are factors, aren't they?
Yeah.
But the multiple is 6. 2 and 4 are factors, and the multiple is 8. 2 and 5 are factors, and the multiple is 10. 2 and 7 are factors, and the multiple is 14. Those are multiples. Okay? So, look at these. Tell your neighbor why these are not multiples.
Oh, I mean, because the product.
Aiden, why are these not multiples? These right here? These are multiples because they came from these. Why are these not multiples? Because they added them instead of multiplying. Okay, thank you. So they have to be a product, and it comes from multiplication. All right, so we got this. Let's see, look up, please. Which one of these represents a multiple? Tell your neighbor, please. A or B, and tell them why. Eric, which one? Why? Because it's multiplying, and it's the product, right? All right. And what would be the definition of multiple in your own words? Yeah. Yeah.
A number that you multiply by another number to get a product?
Yes, that is correct. David. Yes. Aiden.
The answer you get multiplied.
Yes. Hunter.
The answer you get from a factor.
From factors, yes. Thank you. All right, so with that said, let's move on. Here we go. Copy these steps, please. Only 6 steps, only. It says, step 1, write the first 5 prime numbers at the top of my page. That's step 1. Write the first 5 prime numbers at the top of my... If it doesn't fit on the front, turn your paper over, you can copy it in the back. But copy these steps, please. Step 1, write the first 5 prime numbers at the top of my page. Step 2, find the prime factors of each number by factorizing the numbers. Start with a prime number. Step 3, draw a Venn diagram with 2 circles, 1 for each number. Step 4, write the common prime factors in the intersection area. Step 5, multiply the common prime factors to identify the GCF. And step 6, multiply our prime factors to identify the LCM. Copy that, please. All right, so here we go. So let me go through this process so you guys can see it at work, okay? So check this out. Writing utensils down, look up to the screen, please. Here it goes. Look up, look up. I'm given 2 numbers, and they're asking me to find the greatest common factor and the least common multiple of 24 and 36. Check this out. Here goes the process. So, I'm going to write 24 and 36. Oh, but step 1 said write your first 5 prime. 2, 3, 5, 7, and 11. Those are my first 5 prime numbers. So the first thing I want to do is with this one. I'm going to start dividing by one of the first 5 prime. I'm going to go with the biggest number that can divide 24. Which is the biggest number that can divide it? 2 or 3. I'm going to go with 3. 3 times what gives me 24? That is 8. Okay. Next, this one can be divided by what? 2, and then that gives me 4. And the 4 becomes 2 and 2. And notice that I circle these because that tells me that I can't do anything else with them. These are called prime numbers. But as soon as I write them like this, these are called prime factors. Prime factors. Why factors? Because they're doing what? Multiplying. And it gives me the original number. Yes? It is called a factor tree. Let me do this also for this one. Which of these divides into 36? 2 or 3? Out of these 5, which one divides into it? The 3. 3 times 12 is 36. How about this one again? 3 times 4. How about 4? 2 times 2. So this is 3 times 3 times 2 times 2. Are we there so far? All right, so we're almost there. This is where we do this. We get a Venn diagram and another one for this one, and I want to see what they have in common. Let's see. Do we have 1, 2 on each side?
Yes.
Yes, so I write it here. I only write it once. Times. Do I have another 2 on each side?
Yes.
Yes, and I write it there. Do I have another 2? No. How about a 3?
Yes.
Yes, this one and this one. Is that it? Yes, right? What's left on this one? 2. What's left on this side? 3. Well, guess what? This part right here is my greatest common factor. What is 3 times 2? Times 2? 12. That's my GCF. Now check this out. To find my LCM, all I do is multiply all of these that away. So watch. We know this is 12, yes?
Yeah.
What is 3 times 2? And what is 6 times 12? 72. Copy that, please. Yeah, you can do it in the back. I know this is more, we're revisiting stuff that you did in the past, but here we're connecting 2 things, the GCF and the LCM. But we're using the Venn diagram. I want to make sure that you understand how to use that. Copy that, please. Okay, write this down, please. Home plate for tonight.
I knew it.
You thought of what? Oh, you thought I forgot? Yeah, I almost did. Okay.
Well, look at my shoe.
Home plate, here we go. Write this down.
Yes.
For number 1 is 12 and 18. Number 2 is 20 and 30. Number 3, we got 40 and 24. Number 4, we got, give me a number, 8 plus 12, 8 and 12, sorry, not plus 12, 8 and 12. And I'll stop right there. Let's do only 4. Okay? I want you to show me with the Venn diagram the GCF and LCM. I recorded the lesson, so I'm going to upload that at the end of the day. Have a good one, guys. There's tutoring today. If I don't see you guys tamales. Or I should say flour tortillas, handmade, no?